Hello, everyone. I'm going to talk about the laboratory test of reinforced concrete arteries under high axial load that I have been conducting for the last couple of years under Professor Jack Maley. So our motivation was to know and understand what is the current performance on these kind of bridges with the current standard details, and if there is a way that we can improve the performance with a better detailment. Caltrans have some requirements for these special bridges that are attached bridges, and they focus on the ductility capacity. The ductility capacity is the displacement capacity over the yield displacement, and the displacement capacity can be computed using the plastic hinge model. For you that are not familiar, this is an equation for the plastic hinge model for a cantilever column. And if you're in a design setting, you want to know the displacement capacity, and for that you need the ultimate curvature and the yield curvature that you can determine with a moment curvature analysis, and there are some empirical formulas for the plastic hinge length. But in a laboratory setting, we can measure the displacement capacity and the curvatures, and we can compute the plastic hinge length. This is useful because we want to know if we can use these empirical equations for other damage states other than the ultimate displacement. We run an experimental program with 9 columns, and for these columns, we have parameters of interest that were the confinement method, the geometry, the axial load ratio that they were tested under, and the amount of transverse reinforcement, meaning the spacing and the quantity. The columns were tested under high axial load and a lateral cyclic load that increases every cycle. We built this in 2 phases. You can see here a little summary in this table. So there were 9 columns, as I mentioned. There were 1/3 scale of the original bridge, and here are the different geometries of the cross section. The ratios that the axial load ratio that we use, the volumetric transverse reinforcement ratios, and the spacing ratio of the transverse reinforcement. With this, we were able to get this a set of data that allows us to get these kind of plots that are like lateral load against the displacement ductility, and we can compare one column against the other and see how the different details help the column to perform with a better ductility or if they don't. Thank you.